Hi everyone, welcome to today's webinar, How ADA's platform team scaled workflows, development workflows with Kubernetes. My name is Rahul and I head growth marketing here at Loft. And today I have with me Robert from ADA. And before Rob introduces himself and takes us through his presentation, a few housekeeping items. We will do the Q&A at the end. We will send out the recording of this webinar. And now with that, Rob, over to you.
Thanks, Rahul. Hi, everybody. My name's Rob DiPolito. I'm an engineering manager at ADA, which is a customer service automation platform. And today I want to talk about how we've used Loft and DevSpace to help improve and implement remote developer environments at ADA. So in terms of the agenda for today, I really want to talk about how obviously we've used it. I think examples are important and how we kind of went in and what we found across our journey of implementing this and with the hopes of improving the developer experience. But I think it's really important to touch on, number one, the benefits of what we were hoping to get out of implementing remote ephemeral environments and explain some of the pain points with our initial development experience at ADA. Walk through the journey because it wasn't necessarily a big bang approach. It was a gradual implementation of DevSpace functionality over time. And then I'd like to talk about what the outcome of those experiences were and how we were able to improve it. And finally, some closing thoughts, really just touching on kind of what we learned from the experience from our development and engineering teams, as well as a developer enablement team. So with that being said, as Rahul mentioned, my name's Robert. I've been with ADA for about a year and 2 months now, and I've worked in the industry for about 7 years as an individual contributor, as an architect, as a people manager. And for the last year and 2 months, I've been really focused on developer productivity, CI/CD, deployment engineering, and cloud infrastructure. So I guess, trying to set the stage, at ADA, we run a lot of our services on Kubernetes. And as a result, having an understanding of how Kubernetes and containers work in general is a big asset when testing and developing. Our engineering teams all across ADA have a baseline understanding of how Kubernetes works and how to monitor their services. But expertise in these topics typically falls with our infrastructure teams. And we also realize that there isn't really a need to have deep Kubernetes experience across all of our engineering teams at ADA because we can provide useful abstractions to abstract away a lot of the complexities that come with operating orchestrated containers and allow teams to focus on the things that they do best, which is building great features for our customers. And not necessarily having to worry about how to get infrastructure up and running as expected. And so our challenge was really, how do we allow our teams to test their changes on our Kubernetes clusters without needing to get into the details, around templating, around how to get access to kubectl for that cluster, how do you, get the CI working in a way that benefits the ability to deploy and work with remote environments. And so that was the initial challenge that we were proposing to solve. And we looked at a lot of alternatives, but ultimately looked to Loft and DevSpace to help us essentially solve this problem. But before we started implementing it, we also leaned into some of the pain points that we initially had with our developer experience. And so these were kind of the three areas that when we were looking at solving this problem, these were kind of additional pain points. Increased cycle times for changes, non-standard development cycles, and an overall lack of visibility. And so when ADA kind of grew as a company and our engineering organization grew, a lot of the ways of working initially didn't necessarily scale as easily. And I think one of the big examples was related to the first point, which is increased cycle times. And so when our teams would essentially push changes, we had a shared development cluster. And when a team needed to push something or test something on remote infrastructure, they would deploy those changes to that service into the development cluster. And as we grew, we had more and more teams pushing changes to this development cluster and to different services within that development cluster, resulting in overlap in changes being pushed to that cluster. If developer A was working on a feature, they would push it to a service, and then developer B was testing something on that cluster on another service. They could potentially get overlapping results because there was non-standard changes into the cluster. And so as a result, it would take longer to debug, it would be longer to test features, and it would take them a longer time to get changes promoted and into our staging and then ultimately into production. The other piece is when I talk about non-standard development cycles, it's really about being as the number of services that we've been developing grew, different teams have different ways of developing locally. And so if it's an SPA, you would use Yarn. Some teams would use npm. If it was a backend service, depending on how you get started locally, it changed. And when developing locally, we have a lot of supporting services outside of that needed to be the same version and versioned appropriately. So if something increased a version, it would break kind of like the local development experience. And so it would cause a lot of toil within teams. And then finally, just lack of visibility. So when something was deployed, being able to see which version was running on which pods and being able to make sure that the pods were healthy and diagnose any issues with pod startup and things like that was obviously very difficult on a shared environment where you didn't have the confidence that you were running the right code on the right clusters and right pods. And so these were the kind of additional pain points when we double clicked on the initial, how do we provide remote ephemeral environments for development teams at Ada, that we also wanted to solve with the DevSpace experience. And so this was kind of what our journey looks like. It's a squiggly line, but what I really like to think is more of like an exponential curve. And the reason for that is it was a journey, and it was really kind of like a crawl, walk, run. There's no crawl emoji, so it's a walk, run, bike. But essentially, we started with the basics. How can we get essentially a remote ephemeral environment that you can generate via a CLI reliably for Ada's core services? And so that was about 5 services make up Ada's kind of core. And so we worked on implementing that and consistently creating a feedback loop with our engineering teams to get a lot of feedback on the experience, to make sure we were solving the right problems. Because I think, especially as a team that's working to support our engineering teams, it's really important to treat it like a product. And it's really important to get feedback early and often, and not just for the initial release, but over time as well. And so the first iteration was DevSpace deploy. And that essentially allows you to, pull a repo, run a command, and it would generate essentially the ephemeral environment within Loft. And it has kind of like the controls that Loft provides you with, such as like the remote sleeping, as well as the automatic deletion, which helps with resource management and things like that. The next phase of that, which was the DevSpace for development. And so this was like, how do we allow engineering teams to use the DevSpace dev functionality? So for people who may not be familiar, the DevSpace deploy is essentially taking your application, packaging it into an image, and deploying that image to a namespace within Kubernetes. DevSpace dev is essentially taking a remote container and pairing it with a local volume on your computer, and it allows you to develop on a remote container. And so the idea behind this was to help solve kind of like the local development standardization pain point that I mentioned earlier. And then once we kind of put DevSpace dev into play, then we talked about DevSpace per PR. And so this is essentially integrating the DevSpace functionality with our CI/CD so that engineering teams could essentially create a remote ephemeral environment directly in their PR by specifying a command in the PR dev space deploy. And it would take that information and it would deploy it to Kubernetes, and it would give them essentially a URL that could be shared across teams. And then finally, it was the final step, or the last implementation that we've worked on with this, was the end-to-end testing per PR. So essentially what this was, similar to number 3, which was the dev space per PR, create an ephemeral environment, preloaded with some data, and run all of our end-to-end tests against that environment. And so again, improving the quality, giving engineering teams the tools that they need to do things easily, and kind of evolving from the initial, hey, let's get a remote environment via the CLI, and let's get it kind of like working with our PRs and working where our developers are. And I think that's where we got a lot of benefit from. So moving to the next slide, just talking about like the onboarding of the dev space deploy. Essentially, the experience that we wanted to create for our engineering teams was that any Ada developer, whether they're the first few days on the job or if they've been working on the code base for years, they should be able to run git clone to clone the repo. They should create a unique space, so Rob's test PR, and then run dev space deploy. And within 5 to 10 minutes, we would expect them to have a workable dev space or Ada environment for that service that they deployed. The benefits that we get here is it allows people to get started quickly, just the 3 commands. Changes to the environment could be easily shared as well. So a big thing that is enabled by this functionality is if you're testing a PR that maybe is a lot easier to deploy and ask somebody to run through a set of checklists on that PR to make sure that it's working as expected, you can generate a dev space environment and you can just share the URL with those teams. If you need to easily share things with product teams, it's a lot easier to do that as well. And it's a lot easier to experiment on as well. So if you want to just, if it's a hackathon or if it's something that you're just trying to figure out how it would behave remotely, you can, in 3 commands, ideally have an environment running on our remote infrastructure, and it's the same way that our dev cluster is working on. So the next piece is dev space for development. And so this was, again, kind of like the whole concept of mirroring your or pairing your local development volume with a remote container and developing remotely. And so what we were trying to do here is reduce the reliance on needing to develop locally. I think, with a lot of changes that happen with dependencies, whether you're running a database locally or a queue locally, or even if your processor changes from an Intel to an M1, these things impact how you can run a service locally. And so if we can abstract away the laptop component and run it in a container that's maintained by our infrastructure team, it lowers the barrier of entry for first-time committers and development teams, and it provides kind of a paved path for development. Moving on to dev space per PR. So this was kind of the piece where we wanted to take the functionality that we had provided by the CLI and pair it with our CI. And so how do we get the dev space functionality working like we worked it in by the CLI? And so what we ended up creating was unique GitHub actions that took the process that we implemented for the CLI and implemented into the PR flow. And so the experience for a developer was I can build my functionality, over time, create the PR, and when I'm ready to potentially merge it, I can just type in my PR, dev space deploy. Our GitHub action will listen for that comment. It will pick it up, and it will deploy the environment, and then essentially into a namespace that is identified by the PR number. and it will reply with some information that's useful to the developer. So, like in the screenshot I have here, it says, hey, we've created this environment for you. Here's some helpful links that I've kind of redacted, but essentially they're just links to logs that you can monitor the deployment with. And there's also links to the actual PR bot itself. Excuse me. So you can actually just click the link and you can, open up the bot. And then it allows people to easily iterate and change based on feedback from team members. So if somebody's like, hey, I saw your branch, it seems like it's not working as expected, can you make these changes? Then we can make those changes, run devspace deploy again, and it will update that environment, share it, and then it can be merged. The other thing that allows us to do through the PR process is it allows us to guide our teams to the support channels that we've built around these processes. So we have kind of like a devspace resource center that we've cultivated internally. And then we also have kind of like our devspace channel on Slack that teams can post issues if they run into them, etc. Yeah, so that's all on this one. And then finally, the iteration of end-to-end testing per PR. And so this was essentially the additional functionality of, hey, can we create a devspace environment and then run our end-to-end test suite against it? And so basically, if a developer wants to run an end-to-end test suite against the devspace environment, they would again just create a command / end-to-end run, and the devspace command would be generated, and then the tests would run against it. Today, we unit and integration. We have automated unit and integration tests that run against every remote push to our branches. And prior to merge, we run end-to-end tests against all of the code that gets merged. And in our release pipelines, we have kind of our automation and tests as well. But this is kind of a means to additionally allow teams to run end-to-end tests as they kind of iterate. So I think in terms of like looking at where we started and then where we got to with our experience with Loft and devspace, looking at the starting point, which was kind of like the shared development cluster, the more complicated remote development, and friction with accessing the Kubernetes clusters. Loft and devspace helped us get towards the dedicated remote testing environments. So today we support the CLI, we support devspace dev, we support devspace per PR. And we noticed that teams are creating a lot of devspace environments for their PRs to make sure that they're working as expected. And so instead of having to rely on pushing a change and then manually testing it and not necessarily knowing if that change is the change only representing the change that they've made, now they have a dedicated environment where they can launch something that's completely isolated in their own namespace so that they know and they have the confidence that these are the changes that represent, the changes in my PR, for example. And when we merge, we can get a sense of the performance on remote infrastructure. On the complex local development side, with devspace dev, we now have a quicker way to set up and test on remote infrastructure. I think the important thing here is to call out is I don't think necessarily devspace dev has replaced local development by any means. Like, I think there is still a bit of friction between how devspace dev works versus how a local environment setup would work. And we do still have engineering teams that have a preference to the local setup, and I think that's fine. I think that there's a lot of good use cases for running there's a lot of good use cases for running devspace dev, but at least in its current iteration, it hasn't fully replaced the local setup, as it were. Something that I actually didn't touch on too much, but it has been very helpful for us is the last point, which is kind of like friction when accessing the Kubernetes clusters. So obviously, our development clusters are pretty locked down in terms of access, or they kind of like were previously. And so being able to, cube control in and get pod statuses and things of that nature was difficult, just because there was a lot of security controls and layers on top of it. But with Loft, which is essentially the control plane that sits on top of the Kubernetes cluster, it provides kind of that RBAC access to a cluster so that engineering teams can monitor their specific dev space deployments. So if I have a dev space deployment, let's in a namespace called, Rob's dev space environment, I could log into the Loft dashboard. I could see filter by Rob's dev space environment, and I would see the status of the pods running in that dev space environment and the behaviors as well and logs associated with it. So if a pod's getting killed for some reason, or it's in crash loop, the potential for debugging is a lot easier, because I can very clearly see how the application is behaving. So I think overall the implementation has been really useful for our development teams. I think there's still a lot more benefit that we can unlock with working with Loft and DevSpace. And I think that a really important learning from what we were kind of implementing here was, to get the initial implementation up and running. It's fairly straightforward. Like the dev space YAMLs are very similar to like how you would configure Docker. However, it's the maintenance and the adaptability to the changing constraints within our engineering org to make sure that the system is reliable and working as expected is really the hard part. And so treating the implementation like a product and not necessarily like a tool, and making sure that it's delighting the customer, which is in our case, our engineering teams, has been super critical to the success and adoption of the tooling internally. And so with that, I'm looking at the clock. I am a bit early on the time, but that is kind of the gist. I know there's been some chatter, so happy to answer any questions.
Thanks, Rob. That was great, and we are seeing some good interaction uh, in the chat. And Andre has been gracious enough to answer the questions while you were.
Yes, Andre is a member of the developer enablement team as well.
Got it. And before we get into some other questions, what's next? What's next for you now that you have achieved this?
Yeah, that's a good question. So I think in terms of the functionality within Ada with DevSpace, we are certainly interested in the enablement piece. Like I mentioned at the beginning of the talk, Ada has a lot of services that we're developing, and we're currently supporting really just kind of the core services that run Ada. But there's a big opportunity, I think, to expand the usage of DevSpace to other services within Ada. And so the challenge in front of us is, how do we enable engineering teams to kind of take the DevSpace configs and the DevSpace YAMLs and apply it to the services that they own? And so I think that's going to be like the big next step. And then again, making sure that the functionality within DevSpace is reliable for all of the teams across all of the services.
Got it. And we have attendees as well as a lot of registrations from various types of organizations. It's small, there are enterprise, there are financial services, there are healthcare. So I want to ask this question, going back to your journey slide, the crawl, walk, run. What was the problem, and looking into the solution, how did it came along? Is it like some developers pointed out to you, or you already had something in place which was not working, and then you kind of get together with developers to see how we can solve this? So can you comment on that?
Yeah, I think we often try to kind of get the pulse from our development teams around how, where there's toil within the software development lifecycle. I think what we knew we needed to do, because we got it pretty clearly in feedback, was provide some mechanism for testing changes on remote infrastructure. And so we knew that was kind of the baseline. But when we started to dig into the specifics around, what about really digging into the problem, and then, we discovered those other pain points, which was like, hey, this is a problem because our cycle times are being impacted, because we have to, share this development cluster. And hey, we have different ways of getting things started, and it's tough to develop locally across different services. And hey, I'd love to see what what's actually happening when code gets deployed. And so it was through that conversations, once we started to really dig into the problem, where we saw there was multiple pieces that needed to be solved with this. And thankfully, like the dev space offering was able to solve most of those needs.
Got it, got it. And how difficult was it for the team to adopt? Were they already familiar with everything, containerization, Kubernetes, and it was like pretty straightforward? Or if DevSpace and Loft was able to help you, like, oh, you know what, we don't need to worry about what's running in the back end, and we just put one command and it's working.
Yeah, like I said, I think our engineering teams are fairly well versed in Kubernetes, but not necessarily. I wouldn't necessarily say like experts. And so the abstraction that is provided is very helpful, because then you don't necessarily need to get into the weeds of Helm templating and things like that. They just need to necessarily, and especially when it comes to spinning up a remote environment, it should be something that's fairly straightforward, and DevSpace makes it such.
Got it. We have one question from Darshan, and he's asking, what was the impact to development costs of adding this tool?
Yeah. So development costs. So I guess there's two aspects to it, right? Like there's like a capex and then like an opex. Like, like the developer productivity. The implementation of DevSpace resulted in shorter cycle times. So the ability to ship faster was something that we started to realize with the implementation of something like this, and the ability to experiment. When it comes to the infrastructure costs, the obviously spinning up some more pods for these remote ephemeral environments would impact kind of like the operating cost. But the good thing about Loft DevSpace is they do have functionality that, if an environment is not active, those pods are spun down and they go into kind of like a sleep mode. And with our GitHub Actions, when a PR is merged, those remote environments will be deleted. So they're only really active for when they're needed. So the actual impact on the cost of running the actual pods themselves is fairly negligible. And it also comes into how we implemented the dependency management within DevSpace, but that's a different question.
Got it. Yeah, yeah. But yeah. It's good that you mentioned the sleep mode. And for the folks that are not familiar, Loft has this feature called sleep mode, where literally you can set up different times, different days. Let's say on the weekend, you don't need to have those environments. You can spin them down, and then Monday morning you can spin them up. It's very, very simple interface, and it helps a lot in terms of cost savings. We have another question from Valentine. He's asking, what is the size of your team and number of services? Yeah, right here. You can see on the screen here.
There's one active PR, and you end up with 100 environments. What's the operating of this thing? Yeah, so I think Andre attempted to answer the question in chat, but it's also currently, at least via PR, the dev space via PR, it is an opt-in functionality. So if a developer is just updating a README or updating a test, and they don't necessarily need a remote environment, they don't need to specify. They wouldn't say dev space deploy, and it wouldn't create the environments. We are thinking about changing that to a more every PR would get a dev space environment, but that's not necessarily on the table yet. So everything today is opt-in. So if you want it, you can ask for it. But if you don't want it because your change is small, then you won't get it.
Got it.
Excuse me.
And then when I see your title, it says the DADE team. Can you talk a little bit about structure of that team and how it was formed, or why it was formed?
Yeah. So the DADE team, excuse me, stands for Developer Automation and Deployment Engineering. And the team was initially formed to help improve the developer experience, and through building tools for our internal teams to help support their ability to deliver features to customers. So the initial mandate was, how can we make our tooling as well as our CI and our CD work really well for our teams, and allow teams to move quickly and safely and reliably. And so the team kind of oversees tooling, so things like Loft and DevSpace, but also like secret operations, all of our CI/CD. It all kind of falls within our team.
Got it. I'm just looking for the next question here.
Yeah, I think it's worth mentioning in the chat that I guess Andre is bringing up, like, we actually had built a version of DevSpace ourselves internally, and when I think there's a lot of like ephemeral remote environment products, but the value that we got was being able to like take a lot of that custom code out because of the maintenance overhead that came with it, and rely on something that is supported by a strong community, as well as giving us tools and features that really help us, like the sleeping and the automatic deletion.
Yeah. Oh, thank you for mentioning that. And for the folks who joined and who registered, you can head over to slack.loft.sh. I will put that in the comment. And you can ask, you can kind of engage with our community. You can ask questions. As Rob is mentioning, we have DevSpace, one of our open source projects, and we have another open source project called vCluster, like virtual cluster. So you can engage with both the communities there. So I will definitely encourage you to go to slack.loft.sh. All right, Rob. I think we have covered most of the questions. Any closing thoughts?
No, not really. This is my first time doing one of these, so appreciate the questions. I think that, like I said, the true value in hearing, in my opinion, a lot of these talks is kind of the learnings, and some of the things that you might not necessarily read, like in documentation, and what went well and what didn't go well. So I'm happy that I'm able to kind of share our experience, and hopefully it was useful.
Oh yeah, I'm pretty sure it was super helpful, and thank you for your time. I know a lot of things going on in terms of work front, but yeah, it's great that you spared us some time.
Yeah.
All right. So, thank you everyone for joining. As I said before, we will send out the recording. If you have any more questions, please head over to slack.loft.sh. If you want to have a demo with kind of your setup and all the custom needs, you can request a demo. Go to loft.sh and you can quickly request a demo. We'll be happy to take those calls. And in addition to that, one thing I will mention is next month, mid next month, from April 18 to 21, we will be in KubeCon Amsterdam. Loft is having a gold sponsorship booth. The booth number is G13. So if you're, by any chance, if you're heading there, please visit us. Please stop by, say hi, grab a t-shirt. We can have conversation. Uh, and actually, one of the team members, ex-team members from Ada, has a talk at KubeCon. So if you're there, um, please join that talk, and I will also send that link in the email as a follow-up. Um, and yeah, once again, thank you everyone. Thanks, Rob.
Yep. No problem. Thanks, Raul. Thanks, everyone.
Alrighty, bye.